So this is the, so when you draw this, you'll get this. This is a standard normal curve. In the standard normal curve, this mean will be 0. The mean will be 0, and you will have a z score. You will have a z score on the x-axis. Right? This is your standard normal curve. So your z will be 0. Your z will be positive 1, 2, 3, and this is minus 1, minus 2, minus 3. Remember this is asymptotic, so this will never touch it. But for all practical purposes, within 3 standard deviation, the whole data is. So therefore, for all practical purposes, we'll be considering z score from. Now we'll be doing more about the z score later on. Right now, this is just to give you an introduction what a normal curve is. Okay. So for the standard normal curve, normal variable z, so standard normal variable, what that is, we'll be understanding that. Okay, from x, how will you calculate z, that I'll be teaching you. Right now, assume that you know z. Z is the variable that we use with a standard normal curve. A standard normal curve is one in which the mean is equal to 0. Mean is equal to 0, and your standard deviation is 1. So it's a standard normal curve when the mean is 0 and standard deviation is 1. By default. Right? So remember, the tables were made for a standard normal curve. Okay, now how do you have a real life data? How do you convert that into, how do you standardize it? That's another thing. But this is a standard normal curve. So what you have to do is, when you're finding the probability, a probability is area under the curve. So now to understand this, at this point z is equal to 0. That's your mean. Okay? Z is less than minus 2.7. So minus 2.7 will be here. Z is greater than minus 2.7. Sorry, Z is greater than minus 2.7. So this is the area that you are finding. And the area under the normal curve is the probability. Of getting greater than 2.7. Correct? So minus 2.7 is less than Z, or Z is greater than minus 2.7. And this is what we do. And you don't have to do anything by hand, you have to do it on calculator. Achha, when you go to university, you have to read tables for this. In IB, you are doing it with this. Okay? So what we have to do is, you take your calculator, you go to statistics, go to distribution. What kind of distribution you are doing? Normal, no? We are doing the normal distribution. Correct? You'll always be using NCD. What is NCD? Normal cumulative distribution. You're doing normal cumulative distribution. NCD you'll be doing. You'll take your data as variable. Okay? Low limit, you'll take minus 2.7. You take the low limit as minus 2.7. Upper limit, you'll take infinity. Take a large number. Take any 10:10. You can take any large number. 10:10 you can put in. Acha, standard deviation 1. Mean, in this case, because you are working with standard normal distribution. So when you are working with standard normal distribution, you have to remember that. Acha, otherwise, if you are working in any other distribution, you have to know the mean and standard deviation. You put that and you will get the answer. So we will be doing those sums also. You press enter. So what's your answer? So probability that is 0.3 significant figures we have to 997. So that's what you have to do. That's it. Easy. So do the remaining two sums. So these are the answers, 0.0594, 3 significant figures you provide. So what does this give you? It gives you the area under the normal curve. Now the equation of the normal curve you don't have to remember. What we are interested in the area, and that area gives you the probability. That's the logic. Okay, how will integration come up? Yeah, you integrate the function from minus 2.7 to large number. Now you have to integrate that function.
To infinity,
yeah. But the point is what? The calculator has done all that in the back end. So you don't have to worry about all that. So you don't have to actually do integration. So it's a definite integral. It is a definite integral, but you don't have to do it. So again, in this case, suppose you exit and you put in the values. What is the lower? Lower is 1.35. Correct? Upper is 1.94. Okay. If you go down now, there's a graph. You can draw the graph. And it shows you that. You can see that. So what is it showing you? It's showing you the probability is 0.0623, and this is the region that we are looking at. And for all practical purposes, your plus or minus 3, the whole z fits in there. Now z tells you the number of standard deviations away the number is from the mean. So you at z is equal to 0, that's your mean. And z is equal to 3, it's 3 standard deviations away. 3 standard deviations above the mean. This 3 standard deviation above the mean, this is 3 standard below the mean. So basically 6 standard deviation the whole data lies. 99.99% of the data lies. How much lies between one standard deviation? So see, if you want to do that, you can come to know from that. So you take your lower as -1, upper is 1. How much percent of the data lies? 68% of the data lies. 2 standard deviation. So see, you take -2 and 2. 95.4%. So and 3 standard deviation. 99.7. So that's your 68. What are the numbers that I got? 68, 95 and that's the rule. Between 1 standard deviation, this one lies. 2 standard deviation, 95% of the data lies approximately, and 99.7 lies between 3 standard deviations. Now, why is this useful?
Maybe like if you have some data that is very highly rejected or does not lie.
Yeah.
Then
If you're manufacturing something, if you're manufacturing, let's say, ready-made shirts, what shoulder length will you keep? What is the standard deviation? How many will you manufacture? So within 1 standard deviation, you have to manufacture 68% of your raw material. No, it's pointless manufacturing for extra large size. Huh? Because it will be, you have to all put in sale only. Because nobody will buy it. I mean, you don't have that distribution only.
Even for actuary, it can be very helpful. Right?
Yeah, actually, it was very useful. All this
Because they
so,
can just find all the
correct. So all this is very important for you to get an idea. And that was called normal distribution. Because everything in the world more or less follows this. Remember, this is more or less empirical. It's not exact. The problem is statistics is not exact. It's approximate. You will never get always 68%. But generally it's around 68%. Yeah, so you got these answers. Somebody tell me the answers so that people are watching this can and tell me the correct answers, otherwise they'll get confused.
0.0.
So 0.0623. Correct? This is 0.290. 3 significant pairs. 0.601. Okay. Yeah? So very good. Very simple. Okay, by the way, it may not be written so nicely. One second. Let me draw your attention to this. This can also be written like this. Rather than giving a note, then we give you like this. What does this mean? The variable x, continuous variable x, follows a normal distribution with mean as 8, and what is 4?
Variance.
Variance, not the standard deviation. So normal distribution is defined by two parameters. You have the mean and the variance. Now, the problem here is, if you look at your calculator, so you want greater than or equal to 6. So lower limit? 6. Greater than 6. Upper limit? 10 raised to 10. Standard deviation? 2. Now that's very important. Your calculator, you have to enter standard deviation. But the parameter you are writing in variance. So be careful of that. Don't make that mistake. Don't enter 4 by mistake. You go wrong. 2. Mean is going to be 8. Now because you know the mean. You can go down. You can graph it also. That will also give you an answer. The graph is just a way of. This is what you can see now. What does this mean? Yes?
Like the probability of obtaining a value that being greater than 6 is this area. Like
Correct. So probability, if you have a data whose mean is 8 and variance is 4, the probability of getting a value greater than 6 would be 0.841. That's what it means. Correct? This one? Huh.
So, but how is this continuous? Like,
Continuous. That is continuous. X is greater than or equal to. Something measurable. Continue measurable. Suppose you are measuring the length of the arms or 8 centimeters. Okay, the length of the fingers. Let's say. I'm just giving an example. Now somebody's finger would be 8. Somebody's finger would be 8.02.
oh, like that's okay, yeah.
Somebody's finger would be 8.03. You know, so the numbers can be continuous. The values can be continuous. Next one. 0.841 and this is
433.
0.433. Okay, now again, what did you put as the lower limit?
4.999.
No, 5.
Oh, but it wouldn't make a difference.
It won't make a difference. You have to put 5. Unlike binomial. You remember binomial what we used to
Right,
do?
because it's discrete.
Because it was discrete.
Whole number.
So in binomial, if you have the same sum appeared, in binomial, suppose if the same sum appeared, no? For binomial distribution, you'll put the lower as 6, upper as 8. Because there's no value between sides, it's discrete. But in this case, you put these numbers directly. So what's your answer?
0.43.
Correct? So no need of doing anything over here. Here you just directly enter. Less than 9.5, low limit? Negative 10 is to 10. Upper limit? 9.5. Put 9.5. Consider continuous distribution. So what's your answer? 0.77?
3.
Check your answer, check your working. I'll show you a much more efficient method. But I'd like to draw your attention to the form. If you look at the form, when you're filling the LCD, you first have the lower limit. Look here. Lower, you have the lower. You have the upper limit. You have the standard deviation. And then you have the mean. So if you forget the syntax, this is the syntax. Now, I'll start with 9a. Probability x is greater than 28, given that x is greater than or equal to 26, will be probability that x is greater than 28 and x is greater than or equal to 26 divided by probability that x is greater than or equal to 26. Now, what does the numerator become? So now think of a number like, if you have 26, 27, 28, greater than 28, this is greater than 28, greater than or equal to 26. What is the intersection? This is the intersection. Intersection is both the areas. So greater than 28. So my numerator becomes what? Probability x is greater than 28 divided by the probability that x is greater than or equal to 26. So what will I do is menu I'll go to run. You can also, obviously take the decimal values from that and do it. Then you go to options, stat, distribution, normal, correct? I'll take a fraction, NCD. I know the syntax, lower limit, upper limit, correct? Standard deviation and mean. So standard deviation is 2 and mean is 24. Close brackets, and then the denominator NCD means I don't have to copy the values. Otherwise I have to copy the values from the calculator to the paper, and from paper again you have to type that in. I don't like doing this. For me time is precious. Correct? So lower limit 26, upper limit 10 raised to 10, standard deviation 2, comma 24. So I saw a few answers 0.143. So I think so few children got it right. That's very good. But you followed how to efficiently do.
You get the number.
How did I get it? Okay. So you go to, okay, you'll be here. You go to option, stat, distribution, normal, NCD. Now in exams if you forget what the order is, you see that and see what the order is. The same order you play. The same order you play. So lower limit, upper limits, you don't have to learn it, you can just look at that and just do the same thing. The next one, part B. Part B, probability 26 is less than x is less than 28, given that x is greater than or equal to 27. So that will be probability 26 is less than x is less than 28 and x is greater than 27, greater than or equal to 27 upon probability x is greater than or equal to 27. Now again you think of the number line. So if I think of the number line, let me erase this because I already have this. So you think, now 26 and 28, okay, you have 26, you have 28, correct, 26, 28, and you have this greater than or equal to 27. What is the intersection? That's my intersection. So that will be my numerator. So if I combine this into a single thing, so probability that your 27 is less than or equal to x is less than 28 divided by x is greater than or equal to 27. Put this in the calculator. So fraction, LCD, what is that, lower limit, upper limit, 28, standard deviation, mean 24, correct? 24, this is again NCD, this is greater than 27, greater than or equal to 27, 27, 10 raised to 10, correct? 2 and 24. Yeah. So 0.659. Now here what is happening over here? So if I draw graphically, if I draw a graph, your x follows a normal distribution, the mean is 8, variance is 1, standard deviation and variance is 1. Now that means I'm having a curve, normal curve which is having the mean of this is 8, the standard deviation is 1. Okay? X greater than c is point, so there's some value c. Now remember, this area above the mean is 0.5, below the mean is 0.5. So 0.9 means obviously this whole area is 0.9. Probability is the area. They've given you the probability. There's a c value above which the area is 0.9. Means from the probability you have to find a variable value. Up till now, from the variable value you are finding the probability. So I don't do inverse normal. I mean, you know, you can go menu, you can go to statistics, you can do solve n also. We'll check whether solve n is coming in. But the easiest thing to do is do inverse normal, fill up the form. Fill up the form. Now tail. Right tail, because the right tail is getting shaded. Area is your probability. Remember, area is the probability. Area under the curve is the probability. 0.9. Standard deviation is 1. Mean is 8. 6 points here. So inverse normal is also working. I mean not inverse normal, what do you call it? Solve n is working, but do this. So that means the value of C. How do I? Arey Baba, use inverse normal. Don't use solvent. I'll tell you because the left right is there. If you mess it up, why you mess up with your life and your college admissions? Okay. Try part B. If I ask you a simple question, will it be above 8 or below 8? You have this. Correct?
Below.
This is 8. Now what is the area? 0.6. You want less than 0.6. So this area has to be point, how much? So that means your answer that you get should be what? If you get it below, it means you made a mistake. Therefore, you know, always when you're doing inverse normal, sketch the curve first. I always sketch. So now what will you do? Tail, inverse normal, tail, left tail, area, 0.6. So 8.25. Okay, if you want to use the right tail, what area will you use? 0.4. The area of the curve is 1. I mean, you can do that. Each state, why do all that? Yeah, no, not an answer.
If you do
0.4, you subtract it from 1. So what are the functions you have to use? NCD and inverse normal. Which is a function you never have to use? You don't have to use. Why is it there on the calculator? I don't know. Ask calculator. So don't have to use it. So NCD and inverse normal. Okay, binomial what you have to use? BPD and BCD. Never use inverse normal there. Inverse binomial there. Okay? Fine. Just remember that. So the word problem based on that. Again, you can try this. So scores on tests are normally distributed. So now, you know, you'll never miss out a question on normal distribution because then it will clearly be mentioned. It is normal distributed. Are you following that? Now generally marks are what? Discrete. But if there is a normal, means you have to use normal. So that discrete is approximated as normal. Okay? So don't worry about that. If there is a normal distribution, means you use normal distribution. With mean as, so your x is a score, follows a normal distribution. With mean is 68 and variance is 8 square. So if you write in this symbol, you write variance. Find the probability that a student scored at least 75 on the test. So probability that your x is greater than 75, greater than equal to 75, at least 75, correct? So distribution, NCD, lower 75, upper, now they haven't given you the upper limit, maximum marks they haven't given you, and they are asking you to do normal distribution, so 10 is to 10 you put it, correct? Standard deviation 8, mean is 68, be careful, it's reverse, be careful of that, correct? So 0.191, so when you write in your paper, at least 75 on the test, given that the student scored at least 70. So that will be what? Probability that students scored between, you draw that number line, you will get this. Correct? Sorry, it will be above 75, that will be this. Sorry, minus it. So above 75, because if you do the intersection is above 75. Upon probability that x is what?
70.
So you can go to menu.
0.475.
Okay, so you do this and you get 0.475. So all of you are getting the same answer. So I will trust the collective decision. Okay. Part C. In a group of 50 students, how many students do you expect to score between 65 and 72? Find the probability and multiply that by 50.
17.
So find the probability. What's your probability? 0.
0.38.
The probability between lower limit as 65 and upper 72. That's your answer. And you multiply that by the number of students. So 16.88.
88.
So that's how much? 17 students. So it's an expectation. So 17 students. So if you try to do this sum, here what's happening is the board of examiners have decided that 80% of the candidates sitting the mathematical method exam will obtain a pass grade. The actual examination marks are found to be nominally distributed. So assume your marks as continuous distribution, because the question is asking you to do so. Mean is 45 and the standard deviation variance is 7 square. What is the lowest score? So basically if you are looking at your distribution, that's your distribution. Correct? The mean is 45. And what is the lowest score? What is the lowest score a candidate should get so that 80% of the students pass? We don't have space in school, so we want them to go. So pass.
So in the end, when we get our score, do we treat it as discrete or not?
Put it not. Put it because they are giving you a normal distribution.
So you put the decimal.
Yeah, you put the decimal. You put the decimal. So statistics, correct? Exit. So exit. So you distribution, normal, inverse normal, correct? Which tail is this? This is the right tail because right side is shaded. Area is your 80% of the students we want them to pass and go. Correct? Standard deviation is 7 and we have 45. So 39.1. So you can say that. So because it's saying it's normal distribution, they are giving fractional marks. So what is the lowest score? So the lowest score should be 39 point. Does anybody who gets above 39.1 will pass it? Standardization comes in. Now earlier we used to standardize to read the tables because the tables were made with mean as 0 and standard deviation as 1. Here you've been given your variable x follows a normal distribution with mean as 52 and the variance is to be found. The standard deviation is to be found. We don't know what the standard deviation, we have to find this. But they have given you an additional piece of information that probability that your x is less than 51.15 is equal to 0.0446. So if I happen to look this on my distribution, so when the mean is 52, 51.15 is your x value and it's less than that. So this is given to be 0.0446. Now if you try to use the inverse normal, you have to find the standard deviation. Isn't it? Okay. So what you can do in this case is, yeah, let me try that. Now here what do we have? What is the syntax if I use the inverse normal? Let me try. I never tried this. Let me try this. Whether solvent works, she tried doing it.
Solvent gave an answer.
Give an answer.
0.5.
0.5.
Yeah.
Okay. So inverse normal. Now if you look at the data, you have the right tail. So what do you put for right? Nothing. Right or left? There's a right or left here to put in. You don't have to put anything. Now the inverse normal. Now remember, By default, your calculator will take the left tail, I believe. I don't know. If you don't put that, area, you have standard deviation, and what do you have? The mean. Correct? So if I try to use solvent, and then I'll do the normal methodology. Let me see what the difference is. Okay, so menu, run matrix, correct, math, sorry, option, calc, solvent, correct, exit, calc, sorry, yeah, option, calc, solvent, stats, distribution, normal distribution, advanced normal. Now left and right, I think so by default it takes the left tail. I'm not sure. Okay? Area.
Just take normal and put x instead of standard deviation.
And then you can equate it.
Huh?
And you can equate it to 0.044.
Okay, you're taking normal.
Yeah.
Okay, that's a better idea. Why am I looking at that? Yeah. So NCD you will take. NCD lower.
10
minus 10 is to 10. Okay. Then 51.15. Then x. Then your standard deviation is, you're finding standard deviation. Correct. And your mean is, yeah. So this will give you, yeah. And this is equal to. This is equal to what?
0.0446.
0.0446. No need of putting x, you can put x also. Yeah, so 0.5 will be the answer. Now I wouldn't do it this way. I mean, this is good. So I use solvent. I didn't use this. I was planning to use this. So you did solvent. Correct? You did NCD. You did low limit, upper limit, standard deviation, mean, correct? And this value is equal to, yeah, and you got the answer. Yeah, fine, I think so this should be correct. Now how do you do this with the tables if you have? Are you sitting with a calculator? So your table, listen, I'll tell you. From this you find the z value. So now this is an important concept you need to remember. Please write this down somewhere. If you have your x, which follows a normal distribution with mean and you want to standardize it. And if you want to standardize it, what do you mean by standardize it? Your x becomes your z, follows a normal distribution, mean is 0, variance is 1. Then you are scaling it down. You are doing a transformation and you are reducing it. So that the mean becomes 0. Yeah, and it just becomes 1. The formula is z is equal to x minus mu upon sigma. To convert your x distribution to z distribution, we use this formula. So what happens is, if I have to do this, first step I'll do is, you know that the probability remains the same. When you scale on, the probabilities remaining the same. What will I do is, when the probability is 0.0446, that's the question, that's in the question, I'll find the z value. So let's see whether your answers are tallying. Statistics, distribution, normal, inverse normal, left tail, correct? Areas, 0.046, standard deviation, because it's a z distribution we're doing here. So standard, this is 1, mean is what? 0. We find a value. This will be my what value? Z value. 6, 9, 9, 6. You can make more significant figures. Yeah, this much is enough. Then I use my formula z is equal to x minus mu upon sigma. My z value is x, the corresponding x 51.15, correct? This corresponds to 51.15. This z value corresponds to the x value of 51.15. What is this? 52, no? So check if you work this out this way, what's your standard deviation? See? 0.5? Yeah. So obviously, the calculator method is more efficient. This is more efficient. But at the same time, I want you to remember this. Sometimes you may get stuck and you may not be able to do it.
Is it in a formula?
Yeah, this formula is there.
So do these type of sums.
Yeah.
So then the working marks will be if you show.
But yeah, you just show this and then get it. Anything which is possible on calculator, you can show it. No problem.
So I have a question.
Yeah.
Because left or right for the tail?
Which one?
The inverse normal for this.
Left, no? We have lower than that. So, a normal distributed variable x, the standard deviation. So x follows a normal distribution. Mean we don't know. Standard deviation is 3.9. So we always write variance. Right? This has been given to you. 71.37 is larger than. So this is 249.8. This is 0.7137. Correct? Find the mean value of x. Simple. You can use your inverse, not inverse, what am I saying? Use solver.
Usually
No
no solution.
solution. Oh, so then you have to use other method. Good, I get this. It's not giving any solution. So the calculator cannot solve for mean then. I don't know. That's the back end of this. Therefore, you have to know that method. So we use solve when the method fails. So you have to use the second method that I showed you. So using the probability and standard normal curve, you find first the z value, and then you apply the formula.
That can be
Z can be
negative. Yeah.
negative, yes, because your z can be negative.
Oh yeah, because it's
No, because
yeah.
it's below. It's basically that means it's below the mean.
Yeah.
Z negative and that value is below the mean. 252.
Yeah.
So your solvent didn't work in this. Okay. So what we have to do is first go to inverse normal, exit. You'll take the right tail. You will take the area. Area is your 0.7137, correct? And it's a standard value because we don't know both the corresponding values we don't know. So if you use 1 and 0, and when you use 1 and 0, you get the z value. Correct? So that's my z. So if I use this, my z value is minus 0.564264. Now use my formula, z is equal to x minus mu upon sigma. My z value is 564264 x. Now corresponding to x, this was 249.8 minus mu, we have to find out, upon sigma 3.9. If you will get mean as 252. So that means you have to know this method.
So then it's better to just use this because you might.
Yeah, use this one. Use this one.